Hi Pre-Calc. This is a really short video on how to graph in 3 dimensions because we're going to start looking at vectors 3-dimensionally, and it's nice to be able to sort of represent what you are working with. So to do 3 dimensions, you're taking your XY coordinate system and laying it flat as if it's the ground, and then that 3rd dimension, which would be like the walls of a room, you can kind of think of it like that. That's the part that is coming up. That's the 3rd dimension. So remember, things like volume have 3 dimensions. So the X and Y represent the area of the floor. Z, that 3rd dimension, represents the height. So if I'm going to graph an ordered pair, so you have an X, Y, Z ordered pair, and you want it to look 3-dimensional, which is why the XY axis is sort of tilted a little bit. So I'm going to go out 4. So 1, 2, 3, 4. Here's 4 on the X axis. 5. Now notice if I go out 5, I'm going to try and count this correctly. It looks like there's one that's really close in. I'm going to count it. 1, 2, 3, 4. Let's say this is 5 right here. If you follow this line out, follow this over. Okay, so that's where 4, 5 sits. Now we want to do a height of 3. This is the part that's a little tricky. So I came out 4, I went over 5, and I'm going to come up a distance of 3. So this back here is the distance of 3. So I'm coming up, actually, no, it's okay. I'm going to come up about that same distance because, again, remember, you're drawing 3-dimensionally. Now, the final place where you end, that is where my coordinate would be. But we want to represent a prism that is associated with this point, because really when you're graphing 3-dimensionally, it's kind of like you're walking along the length, the width, and the height of, say, a Kleenex box. And so let's look at what the rest of the box would look like. So I'm trying to figure out what color to use. I'm going to continue back here, over here. That would fill out the base of my box. And then this height of 3 back here, that's going to be the same height coming up everywhere. And so then we just finish off our prism. And the ray, or the vector associated with this coordinate, so give it the pointy brackets, starts at the origin and would come through a diagonal to the box right there. And the path it took to get there was it came out 4, over 5, and up 3. All right, so let's try another one. -3, 2, 5. So here's your X, your Y, your Z. So this time I'm going back 3. So 1, 2, 3, that would put me back here. +2 over 1, 2, I think I went back a little further. 1, 2 over, that would take me 2 over, and 5 up. 1, 2, 3, 4, 5. So this is a height of 5, and it is that same height that we want to kind of translate over to here. Now to finish out the box, I'm so bad at this. Finish that off. I want that one. Okay, so I want to come out here sort of parallel, and all my 5s are going to come up the same height here, and this one will come up the same height here. All right, that was really bad, I know. Now, the point associated with -3, 2, 5, remember, was, so that's -3 over 2 up 5. That's where your vector would end. So we go back to the beginning, and again, it's a diagonal that basically goes through the prism that you created. That was a really bad one. Let's try another one. 2, -4, 4. I'm going to make this a little bigger. So 2, I'm going to come out 2, Then I'm going to go back, because remember this is your x, that's your y, there's your z. So I'm going to go back 4. 1, 2, 3, negative 4 is back there. So here is the floor. It's like a parallelogram, okay? So we came out 2, back negative 4, and I still need to go up 4. 1, 2, 3. So this is the distance of 4 that I have to go up. So that distance in the back is the same. Here, it's not quite as high, but you do want it to be the same measure. So in the front, they will be at the same, and then we connect our vertices. I always kind of like to do the floor, and then I do the walls and kind of connect it then at the top. But again, what did we do? We did 2, negative 4, 4, so that's where the vector would end. So our position vector coming out of the origin through the prism. All right, that was a decent one. You can kind of see where it is. All right, so all of this is just meant to kind of give you practice drawing these and getting a feel for how the negatives and the positives work. I will be posting a finished solution to this, so you can, I'm going to let you guys go ahead and I would try these next 3 and then check the final solution that I will have posted up on School Loop for you. All right?